Just let me introduce you the first thing here. Like for example, this is the high resolution images. And then if I want to extract a feature within the Unitech area, so I have to create some geodatabase file. So you have a catalog here. If you don't have a catalog, then Windows catalog, you click and then it will come here. Then you go to the one of the folder, you connect one of the folder. For example, I want to do it within this survey section here. Okay. So, and then here I have to right click in a specified folder, and then I have to new, and then I have to build a personal geodatabase. I want to create my geodatabase now. So everything I digitize, extract features will be archived. You see? So I will give a name. I will give a name. T-Seeker Geo database. So that's it. Then from there, I have to build another link again, which is new, and then feature class. So feature class. So the name of the features that I want to create is the academic building. Academic building, and then analysis. I will say building footprint. Building building footprint. So what is the type? So I want to do a polygon features, not a line, not a point, because I want to extract the building footprint. So that's it. Next, and then coordinate system. I will just import the coordinate system of particular background images. So just import, and then I will browse to that particular, that images I have opened. I will go to this, and then I will import the coordinate system of this particular image into my geodatabase. So here it is, somewhere here, data, LiDAR, and then orthophoto. This is the raster data I have opened, which is here. So add. So okay, next, and then there is okay, everything is okay, next. So now, what are the attribute information that I will build? So I need, name of the building, area of the building footprint, maybe the length of the polylines, and then the name of institution, and then the district it is located, and then the province it is located. This is a sample I'm giving, but this is the type of information that you want to build. So number of students in the department, approximate number of student. So whichever information you think, you can type everything here, and then you click finish, close. So that's it, your building footprint has been created. So now you have to go editor here. If you don't have editor, then customize tools, and then editor here. When you click, it will pop up somewhere here. So editor, and then start editing. You have to click on building footprint, continue. So that's it. When you come here, this is the area. So you zoom in, and then this is the academic building that you want to digitize. So I'll click here, 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 here. This is how you are extracting features from high resolution. So remember, below this is the road. This is how edge to edge matching become interesting. So that's it. This is my building footprint, and then I go to do an attribution here. That's it. So the name is I will say this is a department of mining. You can later at your own time, if you want to build a real database, you have to give a full name. So I just say This one is Department of Mining. Area, what is the area of this building footprint? Then right click, calculate geometry, and then area is highlighted. If you want XY, then just calculate XY, but you have to create a, we didn't build when we are inserting a field. I mean, we should have write the name of Eastings and Northings, but we didn't insert it here, but you have to do it later. So area, square meters, okay, so area is calculated in square meters. So the length, we try, calculate geometry, just maybe perimeter. Okay, the perimeter is calculated. And then institution is yeah, PNG Unitech. And then district is a Lake district. And then our province is a Morobe province. And then student number, for example, we can say 500 students plus something like this. And then same length is already here, which will be same as the perimeter. So it's okay. So this is how you create, but you can also add field if you stop editing. If you stop editing, like you have to save edits and then you have to stop edit, and then now you can add field. And add field, maybe you write things. These things, this must be text, should be okay. These things, and then add field, okay, you can put nothings. Nothings, okay. This is a text field, okay. And then you will see here these things created. So yeah, this is not really a point features, so we will just leave it as it is. It might give a summary, we don't know. But when it is a point features, you see, if I create a x coordinate, okay, so it gives a summary location, and then nothings. Calculate geometry, area, not area, y coordinates, okay. So it gives a summary location. It gives a summary location of where the feature is. So something like that. It summarizes it averages the points for this one, all this, and then it gives the very middle location, which is this one here, XY location. So this is how we build a geodatabase. You see. So again, I can go back. And then right click in my given name, geodatabase, private geodatabase, and I will feature class. Again, building footprint is there, so I don't have to build one more features again. I have to complete the building footprint first. So editor, start editing, and then come here. I have to digitize for example, saving and length department, which is here. So I have to extract the features here. I'm still under the same layer, but now you will see what will happen. A different rows will be created. So that's it. I have to go and attribute this here, open attribute. So a new row has been created. So this one is department of saving, and then area. I can calculate the area, calculate geometry, area, square meters or hectares, and then I'll go maybe length, calculate geometry. Yeah, perimeter is simply a length, and then I go what is the institutions, then it is PNG Unitech, district, it is Lay, and then it is Morobe, and the number of students in this department maybe 400. Yes, it is same. So then I can calculate the location, the middle location, calculate geometry, the x coordinates, okay, and then calculate geometry, the y coordinates. The y coordinates. That's it. Okay. So the coordinates has been calculated. It is here. The coordinates for uh, the very center. It is calculated here. So we build a topology here for the one particular features. So again, we can go digitize the other features again. For example, this one here. That's an example. So this one we will attribute it as a mining department. Mining mining department, and then area calculate geometry, area square meters. Okay, and then length also perimeter, calculate perimeter. Okay, and then we go ahead. This is PNG Unitech, PNG uh, PNG Unitech, and then lay. This is lay, located in lay, and then Morobel, maybe around 700 students, and then that's it. It goes. You calculate these things, calculate geometry, area, x coordinates, y coordinates. Okay, so you have to continue on for all the buildings, and then it is under the building footprint. You see. So let's digitize the one more again, which is, we can say, a civil engineer building. It is here. Let's go. That's civil engineering. This one, the other civil engineering building here, just for example, and then other civil engineering building here. I'm just giving an example. At your own time, you have to do it perfectly. So that's it. Maybe that's the civil engineering, and then the other one again here. These are all civil engineering building, something like that. So when we go to the attribute table, we will find out that 1, 2, 3, 4, they are all civil engineering building. So since they are same features, we have to go editor and then highlight them all here, and then we have to go and match them up. Okay, so civil engineering, they become one layer here. So this one is a mining, this one is a surveying, this one is a, for example, yes, mining. Sorry, the other one here is a mechanical department. This one here, this one is the mechanical. So we can write a yeah, we can write mechanical department. So this one is a civil. I'm just rushing here, but at your own time, do it correctly. So calculate the area for the civil. Just highlight this and then calculate the area. So this is how you build your database. This is just an example we are seeing. Remember, if you are doing for whole of Lake City, so all those database you have to archive, you have to build a geodatabase. So data is, so you can easily extract, retrieve, and then do a mapping or produce a thematic map. Okay. Maybe this building has between 600 students plus, and then the other field we can also create for the number of staffs. For example, I will say this one, this thing is okay. You know how to calculate. So I will say save edit, I will say stop edit, and then I will add another field. Then I will say staff. So I will give a text. Okay. Let's see, a field has been created. So later you can move this field. maybe to students number, staff number. So for mining department, there's so you go to editor first, and then you can come editor, start editing, and then you can come. Mining department has 13 staff, and then the category, professors, doctors. If you want to build another field again, the department of surveying has 23 staffs. Department of mechanical has the 34 staffs. For example, this is an example, and then PNG, for department of civil has the 30 staffs. So something like this, editor, save edits, yeah, something like that. Okay, that's it. You can add the other thing also, so you are building up the database. So this is how the geodatabase is created, and then it is imported or exported to the Excel, Access, and then you can link up with the web page on the internet. And then you provide your credentials to lock up your data. It is archived in the system. So we will try create another feature. For example, this one is the different types of building that we have created. So the other I might create now is go to the same database, and then new, and then feature class. So I will say, so here either we can choose a polyline or polygon features, but try polygon first because it is a high resolution. Let's give a new name, and then we have to import the coordinates. Next, and then we try road name, road name, area it covers, and then we can say this the district it is located, and then the province it is located. We can say these things, no things, but actually this is not a point features. Later you can create it, something like that. Let's just stop here. Whatever you think of, you can edit later. So all can be a text. Okay, let's try. So road network, and then we go editors, save edit, stop edit, start edit, and then of road network. So we'll just give a sample here. So be careful, there's a road in, so there must be a mode node, digitize node, because you will come and continue from there to go in. There's a road going in, there's a node here, node here. There's a road going in, so node here, node here. Then we can stop here just for a practical purpose. Here I'm showing you, so footpath here, so node, node, something like that. And then coming down here, there's a road going in. So this is one of the roads, so I will start create this attribute. For example, road name is for example, Kumusi Drive. Kumusi Drive. What is the area? Calculate geometry area. Okay. The district it is located is Lake District. Province is Morobe. And then institution. There must be a field. Add field after stopping, and then add institution here. So the XY has already been If you want to generate the shape, length, or perimeter, then area is automatically created, but we have generated the area here. So again, that's a community drive, and then you go to the maybe this one here, here, come all the way, join. You zoom in and do it. I'm just doing it here. Join, and then you go. If it goes something like that, just click here, and then it will come back. So, and then you zoom in to complete your digitizations. So this one, I will name it. As Independence Drive. Area you can calculate, but however it is already calculated. So district is Leh, and then province is Morocco. So think about other database that you might, yes, the type and conditions is very important. So for example, I will here, come in here, bring down editor, save edit, stop edit, and then I will add field. So I will say the type of road, type, text is okay, and then I will say add field, and then condition of the roads, condition, and then text, okay. So for this community drive, the type of road is I will say editor phase, editor start editing. The type of road is bitumen, and then for Independence Drive, the type of road is also bitumen, but it might be like concrete. And then the condition is excellent condition. This one is not really, for example, this good, something like this. So this is how you build the road information. Remember, you don't have to match it because it is a different road names, something like this, but you have to create a clear line cut. So the other features you might want to create is a, for example, forest or trees. So you will digitize all trees, also palm trees, and then you rename them. This is the palm tree, something like this. So this is how the geodatabase is created. So you see what we have done. There's data is starting to build up. You see, data is started to build up. So if you are creating a huge area, feature digitizing and extraction, this is how you will create your geodatabase, and then you will archive. So simply after it is archiving, you can simply do a mapping. When you go properties here, when you go symbologies, categories, you will say name. So name, and then you will add all values. So mining, civil, surveying, and then mechanical. I have wrongly spelled, but this is just for a practical purpose. I mean the yeah. So when you apply, you will see the different building layer has come. You can change the color, for example, to maybe red. So these are the civil buildings. This is surveying and lands. This is a mechanical. This is a mining. So something like this, and then these are the road. You can also classify the road, properties, categories, road name, add all values, Independence Drive, Commercial Drive. So this is it. And then when you remove your images, you have already a what here. So you can label features, for example, footprint building, label features. So civil department, surveying, mining department. You see, and then for the road, you can label features. You see, Independence Drive, Commercial Drive, something like this. This is all about the uh, geodatabase creation using a points, lines, and polygons. So you have a raster images, you can convert to the points, lines, and polygon, and then you build up something like this. Create a field, and then you build it up. So again, you will see here there's one of the raster layer. So this is a sandy soil, peat, clay, and then silt, clay, loam sand of the soil textures of the Morocco province. So the base is you have to convert this to vector layer. You have to do a conversion. You have to do a conversion raster to polygon here. So when you click on this, you just input this raster, all of them will go to the polygon, then you merge them up, and then you merge them up, and then they become a vector layer. So it will be very easy for you to handle it this way here. I mean, create a field, add a description, add a values, add a numbers, add an area, XY locations. All these things you can simply do it here. So there's a different raster surface. This is the other raster that I'm oiling, and then this is the other thematic layer raster surface. You can simply create a legend or map here.